In Python, there are many ways to create arrays. So one is using the Numpy module. And what the Numpy module allow you to do is create arrays very quickly. So here, as you can see, I have code basically to create an array filled with zeros. I have code here to create array filled with ones. I have code here to change the data type of the array. So we'll see that in this demo shortly. And I have arrays that actually let you key in a specific value and create it. So if I just run this and we can go through it line by line. So here, you can see here, first we create an array full of zeros. So this happens because we use the zeros function here and we're creating a 3 by 3 array. So that means 3 columns across and 3 rows down. But as you can see here, we've got the 3 by 3 grid. Now notice this is a float data type. So by default, Python will actually create a float data type for the array filled with zeros. So the next one, which is you can actually specify a parameter or an argument into this function called ones and ask it that you want an integer data type. And again, you could do it for the zero as well. So make sure, it gives you an int data type. So here, as you can see with the ones, we now don't have the floating point. So we don't have the decimal here. So now we just get integers. So again, it's a 3 by 3 grid, but now it's all filled with ones. So you can see where you can use that and what are the possibilities. And here we have another one, but notice it's the same one as before, ones, but this time we're asking for the string data type. So as you can see here, everything is surrounded by a single quotation mark there. So again, 3 by 3 grid, but it's the string data type. But you can get creative with this. And if you have all ones and you do another 3 by 3 array, if you say you want a Boolean data type, then you will end up with true, everywhere because ones are considered to be true. If you create an array of zeros here and you select the data type to be a Boolean, of course, you're going to end up with all values being false, false, false. And here we now have a matrix of 3 by 3, which is all false. And then the one which is full, so you've seen we've had ones, we had zeros, and now we've got something called full. So that is the same. And notice that I am doing 3 by 3. And notice this time I've supplied 7. And if you do that, you will end up with a grid which is of a specific value, in this case 7 by 7. So the question becomes, the 7 is an integer. Can it be converted into a float? Well, you could do that. So if I go here and copy the data type that we want, and let's say we say it has to be a float, what will happen in this instance? So if I run this again, and as you can see, we do get the float. So by default, because we said 7 here, and that's an integer, but we can convert it into a float. Now you don't have to do this. So you can just delete that, and instead you can just pass it this value. And what it will do, if I run this again, and as you can see, it's float by default because we've specified that this is the value we want. So you don't have to supply or convert your data type there. You can actually just apply it here. And you can, of course, it doesn't have to be that. So you can actually convert it into a decimal. So again, if I run this, and now you can see I now have an array filled with the 7.67 value everywhere in a 3 by 3 grid. So yeah, this Numpy module is really useful to create arrays, and you should definitely make use of these functions. Other really useful functions within the Numpy module are a range. So this will let you create an array that starts within a range and then linear space. So these will be evenly spaced out numbers. So if I run this code and just to show you what it sort of means, so you can use the a range function basically to give you numbers starting from 1 to 10, excluding 10, and you can ask it to give you a step. So every second number. So it starts off at 1. Then, the steps by 2 to 3, then 5, then 7, and then 9. And here you have the linear space. So this will evenly spread out numbers between 0 and 100 into 5 equal parts. So here, and you can also apply data type that you want. In this case, I've gone with int. Otherwise, you will get a float by default. So here, you can see the numbers from 0 to 100 are split equally into 5 parts, starting at 0, and then 25, 50, 75, and 100. So this is now including the last number in there. So yeah, these two functions will be really useful if you want to create an array of a range starting from a certain number to a certain number. And then you can also create linear equal parts of an array. So here, for example, I could easily increase that number to 100, and I can easily change this to 1,000. And what you will get is you can see how powerful this is. You can see I've quickly got numbers up to 99 here, stepping every second number. So this will be really useful in your maths projects. And here you can see that the numbers are now equally split between 0 and 1,000, whereas this task done manually will take you a long time. So just make sure you use linear space, lin space, and a range to create arrays like this in your code. In the Numpy module, you have the ability to find out the shape and the size of the array by accessing the two properties of shape and size. So here we create an array as shown here. So if you want to find out what shape is it and what size is it, if I run this and we'll find out what it is. So we've got an array here where we get the output for the shape is 2, 3. So what does that mean? 2 means it's 2 rows. So one row is here and the second row is here, and we've got 3 columns in each row. So here we've got 1, 2, 3, and then the size is basically the number of elements. So we've got 1, 2, 3, 4, 5, 6 elements in here, and that's what we get shown here. So you can use these two properties to quickly find out what does your array look like. Using the Numpy module, you can access some really useful properties about your array. You can find out the shape of the array, the size, the number of dimensions, the data type that it contains, and the size of the item, such as how much space in memory is it taking up. If I run this, and just to show you what it looks like, so here we can see the shape of the array. So the shape of the array is basically, it is 2 rows and 3 columns. So as you can see, we've got 1 row here and 1 row here, and we've got 3 columns in each, so 1, 2, 3. And how many elements do they contain? So that's the size part. So this one contains 6, as you can see here, and then we've got the next type, which is how many dimensions. So dimensions, it says it's a 2D array, because what we have is, you can imagine 2D arrays are like Excel spreadsheets. It have rows and columns. So here we've got 2 rows and 3 columns, and that's what the shape is. It's a 2D shape. And then we've got here data type. So of course they're odd integers. So we've got int 32. And how much space did it take? So we've got 4 bytes being taken up. So if you wanted to work out what is the total space being used up by this array, well, you can multiply the size, which is 6 elements, by 4, and you have the total space being used up by array, which in this instance would be 24. So here, that's how you can use these properties to quickly find out some really useful information about your arrays, and these would really help you in the work that you do. Today, we will look at indexing arrays with positive and negative numbers. It is important to understand how to access arrays using indexing in Python, especially for the Numpy module. Here, as you can see, I can access the 1D array element using the index number. Remember, the index number always starts at 0. An interesting tale is what happens when you keep a negative number. So if I run this code, and as you can see here, the elements accessed here for 0 is 10, because that's the first element. Then it is 30 for element 2, so that's 0, 1, 2. And then for the -1, though, the element that we get is 50. So the reason we get 50 is -1 will bring the last element. So if you key a -2 in here, what you will get is 40. So it's the second to last element. So if I key a -2 in here, and if I were to run this again, then as you can see, now we get the output of 40. So that's what the negative numbers mean when indexing. And as you can see here, the same rule could apply for 2D arrays. So here we have a 2D array. The reason it's called 2D array is because you've got columns going across and rows going down. So here we have 3 columns and 3 rows going down. So here you can access the elements using 0, 0. So what does that 0, 0 mean? So that means the first row and the first column. So here, if we look at that, we've got the value 1. And if we look at the -2 and -2, well, what does that mean? So it's the second to last row, which would be, so this is the last one, and second to last is this one. So this is the row that we are looking at, and then it's looking at the second to last column. In this case would be, this is the last column, and then this is the second to last column, so this would be 5. That's why with the output we get 5. If we do -1, that means it's the last row and the last column, so that means 9 is the output we get, and here it is as shown in the console here. So yes, this is how you do indexing in arrays using the Numpy module, and it is important to understand how it works with positive and negative numbers. Slicing arrays in Python is very easy. So here we've got a 1D array, as you can see here, and we want to get different parts out of it. So this process of getting different parts out of it or extracting certain parts is known as slicing in Python. Slicing syntax goes like that. So here you can put a colon here in the middle, and what you do is before it you put a number and after a number. This is known as the index number. So in Python, arrays start at 0 index. So this is 0, this is 1, this is 2, 3, 4, 5, 6. And so on. So when you say 1, what you're saying is from that's 0, and then this would be 1. So that's 20. And then it go all the way up to index 5. So that's 0, 1, 2, 3, 4, and 5. So this would go up to 50. The reason it'll go up to 50 is the last part of this index is excluded. So it won't include the last element, which is 60. So it would only include up to 50. So it's exclusive. That's an important difference to understand when slicing. So here what we're referring to is start. When you don't key a number at the beginning, it means start at the beginning. So it will go from here and it will go to 20, it will go to 30, and it will go to 40. So if you notice the fourth element, so this is 0, 1, 2, and this is the fourth element, fourth index number, but you exclude that, so you only go up to 40s. And here we've got index 3, and from 3 to the end. So 0, 1, 2. So notice this time it's inclusive. So we are starting at position index number 3, and it goes all the way to the end because we haven't keyed a number after the colon. And then there's another part, which is you could actually don't key in the beginning or the end number. What you do is you then say a step. So this is the every second element. So what you wanted to do is go from 10 and then ignore 20, then go to 30, then ignore 40, then go to 50, then ignore 60, and then go to 70. So this is a known as a step number. And then, of course, what you can do is you can actually reverse the array by using this negative number technique. So here, by keying in a -1 or for the step number, it will actually go reverse the array for you. So it would go from 70, as you can see here, 70, 60, 50, 40, one at a time. Now, if you key a 2 in there, then it will do, every second element in reverse if you key -2 in there. So if I run this, and as you can see, just to prove that all the results that we get are shown here, and you can see here, it does reverse the array here, going from 70 all the way to 10. This is what's known as slicing in Python for arrays, and especially the Numpy module. This syntax applies mostly to the Numpy module, but it may apply to other modules or libraries in Python.